I'm Dmitry, and this is Live Coding Kotlin Native Snake. And I spent about more than 10 years working with Java and JVM, and the last few years I worked mainly in Kotlin. So this talk is rated from the point of view of Java developer for other Java or Kotlin developers, but if you're not familiar with Java or Kotlin, you should still be fine, I believe. And before doing the actual live coding, I thought maybe I should do like a little 5-minute lightning talk, and here is a lightning talk. So what is Kotlin Native? And this is the homepage for Kotlin Native. It's on kotlinlang.org, and it has a simple definition on this page, which is Kotlin Native is a technology for compiling Kotlin code to native binaries, which can run without a virtual machine. So it's basically a normal standalone executable binary. Right. Similar to Kotlin itself, Kotlin Native is an open source project. Here is the repository on the GitHub. It's developed by JetBrains, but it's open source, so anyone is free to contribute, of course. It is still not released, unlike the Kotlin. Kotlin Native is still in beta, so don't expect too much from it, but it actually works. Right. And here is a definition for about Kotlin Native from the GitHub page. It's a bit more complicated, so it goes like Kotlin Native is the LLVM backend for the Kotlin compiler runtime implementation native code. So it's a bit mouthful, so like what is this? Right, so I'll try and explain bits from here. So for example, what does it mean backend for the Kotlin compiler? So this backend is terminology which comes from compilers, maybe not familiar for web developers or like everyone, right? So usually the way compiler works, let's say we have a Kotlin source code file, and this icon represents a file, then compiler transforms it into another language called intermediate representation. It also could be a file, but it can be just in memory. And then from there, it, let's say, transforms it into Java bytecode. This icon means Java bytecode. So this is compiler front end, the first step. This is compiler backend, the second step. And in this particular case, this backend is JVM backend. And Kotlin, as a language, it has several backends, so it also has JavaScript backend. So you can take a Kotlin source code and compile it into JavaScript. And there is Kotlin Native backend. And this is the thing I will be talking about. As you can guess from this graph, it is possible to have like single Kotlin file and compile it into 3 different artifacts. And this is Kotlin multi-platform. I'm not talking about this. I'm talking about just this one path through the graph, right? Also, to clarify, let's say we go into native binaries, right? And this is Kotlin Native backend, but the whole thing is Kotlin Native. So when you use Kotlin Native, you don't need to know about these details. Really, just compile files and get executables out. Right. Then the next thing is LLVM. Here is LLVM logo. LLVM is kind of a funny thing, is that it says VM, but it's not a virtual machine. It looks like an acronym, but it's not an acronym anymore. It was initially, but now it's de-acronymized. And here is the homepage for LLVM. So basically, it's a set of tools for creating compilers. And it's a quite fundamental technology. Maybe it's not as well known as it deserves to be, because if you have iPhone, probably binary, all the apps you run, they built using LLVM. So here are a few technologies which use in it, all these languages, including parts of Graal, but also Rust, Clang, Objective-C. So it's a quite fundamental technology. So Kotlin Native also uses LLVM. So basically what I showed before, Kotlin Native backend does this transformation, right? So it's a bit of a lie. It actually transforms Kotlin intermediate representation into LLVM. And then the last step is done by LLVM. So this way, we can leverage existing tools for all target architectures and so on. So this is basically reusing what community has. So that's what it means to use LLVM on the backend. And then there is this runtime implementation. So the way it works in Kotlin, at compile time, you can have a type kotlin.string, right? And then after compilation for JVM, it becomes Java-lang string. If we compile for JavaScript, then it becomes JavaScript string. And if we compile to native, it becomes K-string. So it doesn't matter what it means, but there are quite a few classes in Kotlin package which are implemented separately for different platforms, and that's what it means to have runtime implementation. So basically, Kotlin Native re-implements all these standard library classes for native code. And it also adds some reference counting and some other native specific code. So this now definition hopefully is a bit more clear. So it's basically LLVM backend for Kotlin compiler with runtime implementation for Kotlin. So here's like, why would you do this? And I just came up with 3 reasons, which I think like relevant for myself. One is performance, but performance in a general, performance in a broad sense, because it doesn't mean necessarily faster. It can mean a bit more predictable runtime, or you have more control over memory allocation and so on. So if you're interested in more like performance, that's a good talk by Martin Thompson. He makes an argument for managed environments, but it's like good of you. It's just performance in a multi-dimensional sense. Right, then there is a thing that I think in Java we live in a golden cage of Java API, so we rarely interface with any native code. Unlike many other languages like Ruby or Python, that's a bit more normal thing to interface. There is obviously there is like JNI, JNA, but they're not widespread. So, and there are lots of C APIs which you could use. Like here's an example. So maybe with Kotlin Native, it will become a bit more normal to just use a C library. Right, so there are lots of libraries. And third reason for Kotlin Native is Kotlin itself, because, and what I mean is if you know Java, Scala, or Groovy, you can easily move to Kotlin, and if you know Kotlin, you can pretty much do Kotlin Native, so that's the easiest transition to write a native code for Java developer. And also it's quite high-level language, even if you like just developing native apps, it could be a good choice. So easier than Rust, for sure. And this is the end of the lightning talk. So I'll do live coding because I think it's almost like a pair programming, but you don't get to type. And I will write this game, minimal version of Snake game. I hope you know what it is, but otherwise you will see it later. Right, and for UI, I'll use mcursor's library, which basically lets you switch terminal into the mode when you can use it as a canvas, pretty much. So it's just the simplest UI and easy to do. So here's a disclaimer. I'm not going to write many unit tests just to save time. That's not how I actually wrote it initially. And obviously, this is a happy path, so this is not how you develop every day. So with this, here is C-line. It's IntelliJ-based ID in presentation mode, just in case. And so I can open here console and just compile it. So similar to Java C, there is executable called Conan C, is Conan compiler. If you're familiar with C++, there is package manager called Conan with beginning C. So these are different things, basically. Confusing, but different things. Right, so this creates a file called program k.exe for Kotlin executable, I guess. You can see this is 700 kilobytes, it's a standalone file. If I run it, it will print PID. So if we look at the source code, what's going on here, so this is normal Kotlin code. Main function takes some arguments. Implicit return type is unit, then we call println, and we pass a string. There is string interpolation, but the interesting thing is here, we do get PID, right? So let me run the same thing from ID. But the interesting thing is get PID, which is, it's a function which we call from C. So just showing, I can run this thing from ID as well, right? So, but get PID, I'm opening here a man page for it, right? This thing. It's a man page, and you can see it's coming from uni std, and that's the signature in C. So it takes nothing, void and return PIDs, basically PID of type PID. So I can extract a variable, specify type explicitly, and I can even like navigate through it and see that underneath is basically Kotlin int. Right, so I can go back now. And I can also navigate to get PID itself. It doesn't really show much, but I can also, from this, I can navigate to select this file in the project view, and you can see this is pulled in into project as external library. And so you can see that there are lots of other OSX-specific frameworks here, but also some libraries like OpenGL and so on. So what's going on here is that Kotlin Native, it comes bundled for different platforms, OS X, Linux, so Windows, Cygwin, and because it's known that for this particular platform there will be available, let's say, POSIX, like for all of these platforms, then bindings come pre-generated. This is why I have this file and can just use it here. So basically, these bindings, they come already pre-bundled with Kotlin Native, but you can generate your own. So this was just hello world to see what's going on. And maybe we should just do an actual snake. So here I'll create a class called snake, and it will have, let's say, cells. It will be a list of cell. And data class is like a sealed class in Scala, is just Podger in Java, and will be a data class called cell. It will have values x, and y, and snake will have a direction, and will have type direction. And direction will be up, down, left, right. And the way we want to create this is probably something like this. So we have cells, and it will be a list of cell 2 and 0. So let's say by convention, the first cell will be snake's head. And then we'll have direction. And in this case, we start with y2. So it will be kind of direction is right. And I can import this thing. And let's say we want a snake to move in somewhere. So we can write for this an assertion. So let's say snake moves. We don't have this function yet, but I'll create it in a second, right? And then after snake moves in the right direction, we basically increment x by 1. And that's the assertion. So let's create member function and just return for now this. And I'll run this from ID. Obviously, we expect this to fail. So what's going on here, another interesting thing is you can see this assert equals, and it comes from package Kotlin test. This is an example of those platform classes. So it's defined in Kotlin, and it's implemented several times for each platform. So in Java, this will become a normal JUnit function, right? And in JavaScript land, it will be some JavaScript framework. And here, it's re-implemented for native. So we can see output here, basically, of course, it fails. And it shows like expected snake 3, 3, 2, 1, but it wasn't, right? Because we didn't implement it here. You can also see there is a stack trace. So our actual code, so it's actual executable here, so it's not run in Java code at all. And here, this is our actual entry point, and this is assertion, and this is assertion framework. So you can see stack trace. At the moment, fortunately, right now, it doesn't do mapping back to Kotlin code. It maps back to 11-bit code only, but it's been worked on, I believe. So also you can see that functions in Kotlin can have named parameters. So there is nothing special here. So there is no new keyword in Kotlin. So here we basically just create a snake, and then we can specify parameters with the names. They're kind of optional. I could have done this, but I kind of like when it's more explicit. So let's implement maybe this function. It will be, so when snake moves, we basically create a copy of the snake, right? And what we want to update cells. I'll do it in a way which is more complicated than necessary for now, but we'll need it later. So let's say we create a new head, variable new head, and it will be the first cell which we move in this direction. And then there will be new tail, which will be, we take existing cells and we drop the last cell. So basically we're not moving the whole snake, all the cells, we just create a copy of the head moving in the right direction and drop one cell at the end. So that's the idea. And then for moving cell in the direction, we can do something simple like this, which is cells coordinate plus direction and shift for this direction. So it'd be direction dy. And here we can define dx and dy for this enum. And I think I mentioned, but maybe it's worth mentioning again. So these are the coordinates, the direction. So we start at the top left corner. And so if we move right, basically, we don't move in x, we move -1 up, and so on. So this will be 1, left will be -1, 0, and right will be 1, 0. So if I run this now, it should pass and should not crash. It might be a bit weird that I'm writing assertion inside main function, but it's the same thing as in Java. You don't really need complicated frameworks. It's just a function which checks something and throws an exception if it's not happy. So as you can see, nothing happened, so everything worked. So let's just move this code to an actual test. Right, so I'm going to the project, opening test, and say class snake tests. Also, you can see snakes plural tests, because usually inside one class you have multiple tests. Every framework got it wrong. This is the right way. So and I say snake moves right, and I paste this code. Also needs direction, import. So, and I can run it from ID as well. As you can see, this is also a Kotlin thing, similar to, say, Scala or Groovy. You can have spaces in function names if you use backticks. So really useful for unit tests, so you can actually use space. And you can see this thing runs. Right, I can also do similar thing from command line. So what's going on here, I can find executable and run it from command line. So this is, again, not Java code at all. So what's going on, ID basically runs this executable and just reinterprets this output in UI. So this was kind of fine to have a minimal snake. So maybe we should do a bit more kind of UI things. So for this, I'll use ncursors, and ncursors, it's kind of similar to some library. You would have special functions, and the first function you would call with ncursors is to init screen. So again, I'm opening a man page, and you can see this comes from cursors.h, and that's the definition of the function. Basically, it doesn't return, doesn't take any arguments, and basically it's function which you normally call first to switch terminal into mode of a canvas, pretty much. And at the end, we need to call endWin to go back into normal terminal mode. Then we want something like width. So we want our game field. It will have width, let's say 20, and height 10. And then we want to create, let's say, a new window of this height and this width. And this is starting position. You can notice this is like a bit backward. That's how ncursors API works. So it's this number of lines and columns. And this function, as you can see here, returns a pointer to some window structure. I'll get to it a bit later, but for now, let's say you have window. And then we need to remember to delete window, because it's allocated on heap. And the main point for creating a window is to be able to draw a border around it. So I'll just do this box function, and at the end, we also need to do some refresh. This is also ncursor's way to basically force that we will actually draw something on the screen. So after, also might be useful to print something on the screen. So say window, and a third line, second column, we print something like this. And this will be our textual representation of snake. This thing will be kind of head with a ton, like pseudographics. And at the end, we also need to read a couple characters. Otherwise, this whole thing will draw it really quick, and then endWin will just like wipe out the whole screen. So kind of need to read a couple characters. So just to repeat what we're doing, we're initializing terminal into a special mode. Then we have width and height for the window. Let's say like this. Then we draw a box. These are just default characters for the border. It's just, we can ignore these things. Then we print the snake. Then we make sure we draw it, and then we read a couple of characters. Well, I could run it from ID. Unfortunately, it won't work, because just when you run it from IntelliJ or CLion, it just initializes terminal in the run mode. So now we can see it actually worked. So if I type 1, let's say it prints 1 back. It's not what we want for the game, so there is a function called no-echo. It will just stop this from happening. And you can also see blinking cursor. This is also not so cool for the game, so we can say, what is called cursor set to 0. So we can basically say, just don't show the blinking cursor. So again, if I put in, let's say 2, and then I press 3, it just finishes the program, kind of as expected. And this kind of looks simple, but there are a few things which are happening. Again, like all these functions which I showed, there already comes bindings for cursors and cursors library already comes, because it's available out of the box on OS X. It's not the case, for example, for Linux, right? So it's a bit more tricky than you think what's going on. It might be useful to look at this function and say which prints a string. So this is the signature in C, so we can see it takes a pointer to window. If we actually go here, oops, oh, what I've done. Yeah, so if we go here and specify type explicitly, as you can guess also, this is Kotlin code, right? So it has local type inference. I can specify type int or I can just remove it. So it's the same with the pointers, like, it's optional. So you can see this is a pointer, and what it basically shows is that in Kotlin Native has a representation for C pointers. So that's how you represent C pointers. Then the next argument which we pass is 3 and 2, like they both ints, but also again here this is Kotlin.int, that's not necessarily C int, right? And obviously, maybe it's not so obvious, but in this case, Kotlin int becomes, after compilation, C int. And the last thing is that we pass in this string, and it's pointer to chars, right? And this is not exactly what happens here. Like, it's not the type that we have in Kotlin, because, for example, I even can do, like, let's say, to lowercase. This is not Java, it's just API which is inspired by Java. That's why it might look like a Java string, but it's totally not. And I'll show how it actually works. So similar to, let's say, even Java string, Kotlin native string is implemented in 2 languages. So one is Kotlin, so that's the actual source code for Kotlin string. I just have it checked out from GitHub and I just open file, right? It's not part of the project. And so you can see this is defined mostly in Kotlin, and for example, this function, this is just Kotlin, right? And but there are some functions which are marked as external, and this is similar to when you see, say, native keyword in Java code. And then you have this annotation with the name, which says what is the name in C code. So I can open kstring cpp, that's an actual C file, right? And we can search it for this function, and this is the actual C implementation, right? And it does some hashing. So the main point here is that this string here, it's not a normal C string, it's just a combination, it's K string pretty much, that's the actual type. So obviously we cannot just pass it to a C function that's just run, right? We kind of can click through this thing, but it doesn't show you too much. So that's another special thing, which you can find it as well, but like I prepared the bridge code, which you can see that it's what's going on here. Basically, that's the function we were calling, and third argument is the string. It doesn't matter like details what's going on, just down here you can see it's doing some special things like .c string, get pointer within this scope, and so on. So basically the whole idea here is that Kotlin Native is trying to make integration with C as smooth as it can, so similar to Kotlin on JVM, which tried to play really well with existing collections and classes. So that's the similar idea for Kotlin Native, to make integration easy. For example, if you did it in Scala Native, you would have to do some additional things yourself. So yeah, that's the idea. So it's like, there are a few things which are going on here. Also, I mentioned bindings and the way they work, and the whole project is set up. So let's say this whole project is set up in an old way, so ignore details, please. So what's going on here, we have build Gradle, it will generate in this, and IDE will basically understand how things work. But here we could also modify Gradle and say, we want to generate bindings for our library, which is called ncurses, and how you do it is defined in this file, ncurses.def. And in ncurses.def, you can specify, this is how you find header file for OSX. This is how you do linking when you produce executable file, and so on. I'm not going to do it this way because it's, as I mentioned, it's already bundled with OSX. But if you do it, for example, for Linux, you pretty much have to do it. And this is how you can generate bindings for any other native library and use it from Kotlin Native. So this was kind of fine. So maybe we should do a bit more things for the game. And maybe the next thing to do some input. And let's say it will be variable input, and while input converted to character not equals to q, which stands for quit. Right, we'll do this thing. We also need to clear in our screen because we're doing it in a loop, and we only need to read the character once and do something like that. And then at the end, we probably want something snake.move, similar to what we had in the test. So I'll just copy it from the test. So we have snake here. So yeah, direction right. And we need to make snake mutable. So this is, now I'll just do minimal thing to see something on the screen moving pretty much. So let's imagine we have field called .head, so I'll just create it. And it will be cells.first. It's quite simple. Also quick refactoring here. And so now we basically have this loop. every time I press a character, every time it will compare input to Q. Well, in the first place, it converts it to character. This is also Kotlin Native function. Then it will draw our game. Then this is a blocking function. It will wait for me to press a key. When I press something, it will just move Snake in the right direction. Obviously, this is just a quick prototype to see that things are happening. So now if I press something, it kind of moves. So it's kind of a bit weird at the end. But okay, if I press Q, it exits. So as expected, pretty much, kind of looks fine. Except that I had to type to move Snake, and that's not so cool, because in actual game it should move by itself, right? And there is a function called half delay, which lets me do this. So what this means is that this getChar function won't be blocking, it will wait for like 200 milliseconds. And then if I didn't press anything, input will become 0. So that's one improvement. And the other, I guess we should just print the snake in a, like, print the actual snake with all its cells, not just some string, right? So I'll use this function called snake, called .let, and what it means, so that's another Kotlin thing. This is just a normal function, and it takes lambda as a parameter, and then inside the lambda there is implicit name called it, and you can, so it within the lambda means snake.head. So that's why we can do it. And another rule in Kotlin, if the last argument is a lambda, you can drop parents. So that's why it looks a bit like some special language structure, but it's not, it's just a lambda. Right, so that's snake's head, and it should look like this. And then we will also want to have a tail, which we print like this. And the tail will be more cells, so let's call it for each. And I'll just create the tail, which is also straightforward. It's like all the cells, but drop the first one. So that should be like an actual snake. As you can notice, compilation is not very fast, and as far as I understand, it's not a single bottleneck. It's also, I guess, problem with LLVM and so on. So it's a known problem, and I guess it will improve in the future. Yes. Yes, yes. I don't know exact details, but I don't think it's been heavily optimized at all, so it's like beta version. So now you can see I don't need to touch anything, and this thing moves by itself. And the only weird thing is just now at the top of the screen, which is not exactly correct. And the problem is that we used width and height as the size of the window, but maybe we should change it so that they mean the size of the game, not just the window. So I'll do +2 here. It's because we have left and right and top and bottom border, so I do +2, and here I need to do +1 when printing the snake itself. Right, so I'll do it all +1. Also, the snake was kind of small, so maybe we should have a couple more cells, say 4 and 3, so that's like looks more fun. Right, and then the next thing to make it a bit more playable could be to make snake change direction. So I'll just write one more test to make sure it moves the right way. So let's say snake changes direction. And the way it will look is that snake can turn down, let's say, and if it turns down, what it means, it changes direction. And this cell will be 2-1 instead of 3-0, so it kind of moves down instead of keep going right. And there is another edge case, which is a bit more tricky, is that what if it was moving right, but we want to turn left? And there are multiple solutions to this. In this implementation, it'll say, let's ignore this, because it's kind of complicated. You could, in theory, just reverse the whole snake. There are different implementations, but it's just more tricky, and let's, in this case, just say do nothing. Right, so let's say member function, which will be new direction. And what we want, if current direction is opposite to new direction, then we just return snake without modifications. Otherwise, we create a copy and update direction, pretty much. That's the idea. And this opposite also should be simple. So let's call this that. And opposite means that dx plus that dx equals to 0, and dy plus that dy equals to 0. So you can see this should work because, for example, up and down are opposite. So if we add up 1 minus 1, they will be 0 and so on. So that's about changing direction in this test. Hopefully it should work. So it all passes. What we actually want to do, though, in the main loop, we want to probably change direction here, say turn in direction. And by direction, we'll mean direction. And we can switch on input and convert it to input, convert it to character. And I'll use IJKL for out, so this is up, left, down, right. I could have used arrows, but it's just a bit simpler to do it this way. And let's say this will be direction left. This will be down. This will be right. We also need to specify default case, and I'll put null into here. And Kotlin will force me to make this parameter nullable and so on. So if you're not familiar with Kotlin, it's because Kotlin enforces nullability of types. It's not really important in this case. Right, so and just to show what we've done, we basically implemented the turn function, which pretty much always updates the current direction, and then we do this switch on the snake direction. And because we implemented move in this tricky way initially, that's why it should work already, and it should just move the right way. So now it can change direction. It kind of goes off the screen, which is not a real thing, but at least it moves and looks okay to me. Right, so also at this point, I showed quite a few things, but I missed crucial detail for any native code, which is memory management, which is completely ignored. And that's like one of the selling points. You can get quite far and by just like not thinking too much. That's not the right thing though. So what's going on here is that, for example, all the design is very kind of functional. Every time we move cell or snake, we create a new instance pretty much. And what's going on is that for classes defined in Kotlin and for Kotlin native objects, it does reference counting and will automatically reclaim memory when there are no references, right? And I think there are plans to make this strategy pluggable, so you can even plug in your own some GC and so on. So, but for now, it's just reference counting. On the other hand, we have this window, which is definitely not owned by Kotlin Native. We just call this function new window, which is just external binary, right? It allocates an object, and then in the end, we need to remember to kind of delete it. And this is a bit more like tricky thing. So I'll just type here some code to illustrate what you can do. So because it's native Kotlin, you can actually just use native heap, and you can just say allocate something, some time spec. And time spec here is C structure. So if I navigate to it, you can see this is how Kotlin Native does C structures. And after you allocate it, you can get, obviously, object. Then you do it again, let's say. And then at the end, you have to remember to do deallocation, right? So something like that. But obviously you can do it twice, and that's an error. Or forget time spec too. So this is like classic C problems with memory management. So obviously, it's not obviously, but it's not the best way. So the second best way is to use arena classes. And arena, it's an object which keeps, you can manage memory by using reference to that object. So let's say in arena we allocate few objects, and then at the end we just need to remember to say clear. And the benefit is that we don't need to pass references to all our objects around. We only have one object, and if we clear at the end, it will clear all the other objects, right? And the third best option is to use this function called memscoped. Again, it just takes a lambda, so it's not a special syntax. And then inside there, you can do, again, similar, allocate some objects, and at the end of the lambda, it will automatically clean up. Obviously, the benefit of this, if you throw an exception, then it will clean up no matter what. It will remember to catch it, so it's less error prone, right? And there is also this twist that you can have something like a destruct. You can have a function called defer, and then you can do some cleanup code here, and the same thing for memscoped. So we can do some cleanup before objects deallocate. And actually, this memscoped with defer is probably the thing we should be using. So just delete all of this bit and use memscoped up there. I'll just wrap the whole main function into it. And let's say this optimize imports. And so, for example, we initialize the screen and then we do end win at the end. But actually, it would be better to do it right here so that we never forget. And we obviously don't need it at the end now. Similar thing with deleting the window. As soon as we allocated it, we just go ahead and delete it. As you can guess, also these differs, they run in reverse order. So delete window will run before end window. So it's all done in a proper way. And so this is how you can do, how you do memory management in Kotlin Native. You cannot, though, allocate on stack right now, so you cannot choose to go and allocate. Also, the thing which I showed was native heap is obviously was a globally available object. Right, so that's kind of was memory management should work in the same way. So let's do quick refactoring before doing more features. For example, let's extract a game which will encapsulate width and height, and it will also contain snake. So it's just a data class with basically all these three things to have ownership. So let's say we have game, we have width, height, and snake. And then we want to use this game instead of using those objects directly. So we don't use width directly. We don't want to use snake directly anymore. And also here, we want something, I guess, something like game update and use direction. This thing will go away. So just create a member function, which will be just, again, creating a copy with new snake inside. So we didn't really change anything, just pushed things around, moved things around. And now this can be mutable. Snake is used once. We can align it, same height and width. We can put them on separate lines and add names. So now we have game. Maybe this area where we draw things, we can extract it into draw function. So it just looks a bit cleaner here. And also, we could change this thing to be there is this refactoring in Kotlin, so there is a thing called extension functions where you can basically pretend that you have a function on particular type. So here we can say convert parameter to receiver, and you can see in the front of the function you get this thing, which basically means this, keyword this within this function will be this thing. And the way we call it also changes, so it's window.drawGame. Kind of looks a bit nicer. Game doesn't know how to draw itself. So just a bit of refactoring. And so the next thing as a feature we could do, for example, show if the detect when the game is over and show it on the screen. So let's say if game is over, then we want to print something like this and do it on the first line. Let's say here we say game over. And on the next line we can say your score is and some game score. This field doesn't exist, so let's create score. Will be quite simple because the whole idea of the game is to basically survive. Snake eats apples, it grows bigger, and then if it's too long you bite itself or hit the wall and then you die. So I guess counting cells is kind of decent proxy for your score. Could be more complicated, of course. And game is over is also simpler than it might seem. So for example, one case is when snake bites itself, so it means tail contains snake's head, right? And another case is when we hit the wall, so it means any of the cells has x coordinate which is not in the range between 0 and width, or similarly y is not in the range between 0 and height. And if the game is over, we should also stop moving the game. So in the game update, we can say if it's over, just return the game, and that's it. So this should pretty much make it possible to lose in the game, which is essential part of the game, unless it's Minecraft, I guess. So now if I run this thing, so you can go left, kind of hits it says game over. Same thing going down. That's a great example for unit tests, really. And this thing and last thing I can try, I may go in top as well. And biting myself quickly, moving around, so it also dies. So the last big thing to do here, of course, is to add apples. So let's create a class called apples. It will also have width and height. So it will be more like an apple field, I guess, but it's a bit too long to type. It will also have cells which represent apples. Let's have a set of cells. And again, unlike, let's say, Java, you can, not unlike Java, but you can have default arguments for all the parameters for data classes. And it will also have growth speed, which I'll explain a bit later. So let's say it will be 3, and there will be some random thing. So just not used anywhere, so we can add it to the game and just create some default apples with the same width and height as the field. And what we want here is pretty much to, every time we update the game, create new apples, and let's say call it apples grow. And will be some, again, member function, which will return new instance of apples. And if, say, random number between 10 is less than equal to growth speed, then we do nothing. So what this means really is that we take a random number between like 0 and 9, and if it's above 3, then we do nothing. So it's roughly 30% or 70% of the time nothing will happen. It's just to introduce randomly growing apples, not on every move, right? Otherwise, we create a copy and we just do cells plus cell, and it will be obviously a cell at a random location. So it will be width and random next in height. And the last thing, we kind of want to draw this to be able to see apples. So we can say apples, cells, and I'll draw them as a dot. It would be nice really to use some emojis or something more graphical. Unfortunately, emojis, they're bigger than 1 byte, so like we would have to use a different n-cursors version. So it's kind of part of n-cursors that everything is 1 byte. So unfortunately, it will be a dot. If we run it now, we should be able to see, like, yeah, cool. We're also printing them strategically before snake, so you see they're not drawn above the snake, and snake just goes through them. So this is like the actual last thing to make snake eat apples and grow, right? And to do this, I'll extract this function again in the game update. I'll call it new snake. And let's say refactor it, just format it a little bit. So say there is turn, snake's turn moves, and then it will eat. And to eat, it needs apples, but apples also need to grow, and if you eat an apple, it should disappear from apples, so I'll just put everything into here so it will be like a bit more functional. And the function will return a tuple or pair, as it calls in Kotlin. So new apples, and we want new apples here, really. So now that's the function which we can create on snake, and it takes apples and returns a pair of basically new snake and apples. One case is when we didn't eat an apple. It's when apples cells, they don't contain snake head. So if it doesn't contain snake head, we return everything as it is. So we return this snake and apples as they were. Otherwise, we return a pair, and we create a copy of this snake with variable called eaten apples. Doesn't exist, of course. I'll create it in a second. And we copy apples and remove from apple cells the current snake's head. That's how like snake eats the head at the snake's head eats the apple at its current coordinate. And let's create eaten apples inside snake. This is kind of to let snake know that it has to become a bit fatter. Right? So eaten apples will be int with default value 0. So what we've done so far is just we remove apples and increment the variable. Now we need to use this variable, and we can use it when we move the snake. So let's say if snake didn't eat any apples, we drop the last thing, the last cell. Otherwise, we won't drop, and this is how it will just grow naturally while moving. Also, we need to decrement eaten apples by 1, but don't want to go at negative forever. So let's do quick thing max off, right? Something like this. And this should be kind of the whole minimal playable version of the game. So let's run it and see if it grows. I will play for real this time, so if it takes a long time, sorry. I'm not just playing, I'm doing UX testing. Yeah, there must be some good strategy. Especially, oh no, okay, fine. So yeah, as I showed before, it's relatively still small, but like 1.3 megabytes standalone file, one thread, unlike JVM, which starts with many threads. Also, if you look at how heap is used, again, it's, Kotlin Native never been optimized, so this is like, we shouldn't really take it seriously, but just to give some idea, so this is valgrind, which is tooling for native code. So I ran it, not now, but previously, and that's the output. So horizontal line is time, even though it says megabytes, that's time, and vertically is heap. Right, and you can see that here it just basically fluctuates around 1 megabyte, even though this is exactly the code which I showed, so it's not optimized. We create copy of objects all the time, so it's like not optimized at all and still quite good. And you can also do better. This is kind of, from game point of view, it's very basic, right? But you can do, of course, better. So this is pretty much the same code, but with different UI. So in fact, it is the same logic of the game, because you see it's a bit, it's not very smooth, because it's the same logic, just different UI using SDL library. So the whole point here is that this is kind of initial step, but you can do better and can do more things with it, right? Just to show, this is the code for what I showed. This game, snake, apples, and cells, they identically the same, but like there is way more code for showing it in proper UI, because it's a bit more tricky how to curve things and so on. It's like lots of details, but you get the idea, right? So there are more native things. What I showed is like very quick intro into what you can do, and there is C and Objective-C interop, and it's two-way interop. I only used C from Kotlin. You can also create a Kotlin libraries which you can use from C and Objective-C. There's also like concurrency with workers. You can do, like, there are other functions. You can look it up on Kotlin. You also get, because it's native, you get all the real native things like genuine memory leaks, segmentation faults when just program stops, so all the good fun stuff. And so there's some takeaways. So if there was some continuous line between like C and Kotlin, I mean JVM Kotlin, so I would say Kotlin Native somewhere there, so it's even closer to actual JVM Kotlin than C, so it's not that low level at all. And it's not a system programming language, but it's very nice to use. And like Rust and Scala native, somewhere left of Kotlin Native, I would say. Rust is definitely more complicated to use. And you can also see the same thing which I showed I re-implemented in Rust, Scala Native, Go, and Graal VM. So if you want to like compare them to each other. Oh, I'll tweet it. Oh, yeah, I can take photos if you want. Okay. Yeah, as a disclaimer, this is early days for Kotlin Native. It's not released, right? So there are a few things, as you've seen. Compilation is not fast. To be fair, like other LLVM tools, also not fast, but also not ideal ID support. What I showed is quite an old version of C-Line, so it might be not easy to set up so that everything is clickable. You're not going to get, I think right now, you're not going to get out of the box Java kind of experience in ID. And like tools are not perfect yet, so what can you do next is basically, it's open source, so there are samples folder on GitHub. Just go to Kotlin Native GitHub, there are samples. You can run them, compile them and run them using Gradle. You don't need ID for this, and just see what there is. And there are some files also on Markdown files on GitHub. They're quite good, I think, well written. And there is obviously on kotlinlang.org there are references, there are tutorials, but I think Markdown files, they're more likely to be up to date and so on. So references, tutorials. There is also obviously on Kotlin Slack there is a channel, Kotlin Native, and it's also, I think it's quite nice because it's so new. The core development team for Kotlin Native is there, and people who actually write Kotlin Native will immediately help you. It used to be the case for Kotlin itself, but now it's like so popular that, like, you know, language creators not always there to answer your question. And overall, Kotlin Native seems like a very interesting technology. So good luck to the Kotlin Native team, and hopefully, like in a few years, it will be a big player in native space. if you liked the live code and something, I created a YouTube channel. There isn't much stuff there, but I'll promise to post more. And this was live code in Kotlin Native Snake. Thank you for watching. If you want, just grab me afterwards. I don't think like mass questions are not that good. Just like grab me, I'll be around. So yeah, thanks.